Okay, hello. So welcome back. So today I will show you about gate drive. Okay. So why we need gate drive? Okay. So you can see here, this is, I give you example is microcontroller. Maybe you Arduino. Okay, Arduino Uno. So maybe you set it as this is the GND1. Okay, and this one is the PWM. PWM signal. Okay, so basically it is square wave 5 volt. Okay, and to switch a MOSFET, let me move this. Okay, to switch a MOSFET here, so you have a MOSFET, I think, if not, okay, something like this. Okay, so this one is collector, I think, or source drain, S D, and this one is G, gate, and this one is N channel. Okay, so if you want to switch this, you need to apply 15 volt. Okay, this one to this one, you need to apply 15 volt. Okay, where is undo? Okay, so you have to apply 15 volt. So you can see the problem here. This is 15 volt. This is 5 volt. This is 15 volt. So not enough voltage. So that is the first problem. Okay. So the second problem is grounding. For example, here, let me move this one. Okay. The second problem is grounding problem. So you have a microcontroller. Okay. This one is this one is ground one. Okay, so you have a power supply here, and then you have the switch, buck converter, and diode, something like this. Okay, this one positive, negative, and inductor, capacitor, and this one and this one. Okay, so LC, diode, and the switch. Okay, so for example, if you connect this into here, so this one, assume that this is the supply, negative, positive, this one is G, this one is S, and not, sorry, this one is positive, this one is negative, this is one is S, this one is drain, this one is drain, this one is source. Okay, this one is G. I think I flipped the top one. Okay, this one is flip also. Okay, so drain, source. Okay, so this one is considered as this ground. Okay, the same one. Okay, we just transfer it to here. Okay, so drain source. Okay, maybe I redraw this. This one. Okay, this one. So this one positive, negative, and then this one is G, this one is S. Okay, and the ground here is here. Okay, something like this. Okay, and if for this one also, if you share the ground, okay, what happened is actually this one will be shorted to this one. Okay, basically you will short this supply. So that's why it cannot like this. You have to have a separate supply for microcontroller and the converter. You need to have different ground. So to do this, you need to have a gate driver. So gate driver is basically to amplify and isolate the signal. So you have the, for this case, the cheapest one that is available is the Octocoupler. is called HCPL 3120 Octocoupler. So basically what it's do is give a signal here. It has LED inside here, okay, and then goes back here, and then it has some sort of what you call LDR, something like that. Okay, so it has switches, something like that, and you have to supply a different power supply. So for example, this one is the ground, this one is 15 volt, for example, because you want to switch at 15 volt, but this one has different ground. Okay, you need to have two power supply. This is the first supply, and this one is the second supply. So you have a isolated ground. So this one is isolated by light. So basically it will convert electrical signal to light, and from light to electrical signal again. So that is the function of the gate drive octocoupler. So this is the cheapest one. Now, right now in 2024, the price is around 7 ringgit. Okay. So how to design the HCPL 3120? So you have the octocoupler here and a microcontroller that produce 5 volt. Okay. And then you need to have a resistor, and you have the HCPL 3120, and this is the notch. This is 1 2 3 4 5 6 7 8. Okay, so how to design this? This one goes here, and then for MOSFET you just connect to the gate at the leg 7 and 6 and 7. So you have something like this. Okay, and then this one is connected to the leg number 5. Okay, so this one's S, G, and drain. Okay, so make sure S is connected to leg number 5, G is connected to leg number 7 and 6. Okay, and this one you need to connect to the power supply 15 volt. Okay, and also connect to the leg number 5. And this one you have a different power supply, plus minus 5 volt, because Arduino use 5 volt. So goes here and then goes here, and you can see here the ground is not connected. The ground is different. Okay, so it's simple, just this one. Leg number 1 and 4 is redundant, nothing, no, I think it's called NC, no connection. Okay, only you use 2, 3, and 8, 7, 6, 5, 6, 7, 8. Okay, the problem is here, I forget the name, RC. Okay, so for this case you have to check the data sheet. So you can Google the data sheet for this one. Okay, so you have to look at the forward current, okay, and the turn on current. Okay, for normally this thing usually change a little bit, depend on the company, but usually it's the same. So the IF, okay, I forward current means that you need to turn on this. Okay, turn on this. You need to have a, let me redraw this. So resistance, and you have diode. Remember I said inside there they have some sort of diode. Okay, so this is RC connection, and this is the diode. The IF, this is IF. To turn on this diode you need 16 milliampere. Okay, and I think much more lower, 7, I think 7 milliampere, and the maximum is, if not mistaken, is 30 milliampere. So make sure, 25 milliampere if not mistaken. So make sure when you design this, it needs to be above 7 milliampere and lower than 25 milliampere. So this one, if you can look at the data sheet here, the current changes. So it's around here actually, so it's around 1.55. that is the standard. So plus minus 1.55. So because of your signal is 5 volt, okay, so if you use Kirchhoff voltage law, it should be 5 volt. Okay, the RC equals to 5 volt minus 1.55 because of the voltage drop here. Okay, then you get the voltage here, and then you divide by the turn on current 7 and the maximum current, or 5 minus 1.55 divided by 25 milliampere. So you have to check the data sheet. Usually they sometimes a little bit different. Okay, so make sure you check. It's quite difficult to find it, but usually it's almost the same. Okay, yeah, it's a lot of data, but don't worry, just design around this parameter because usually they design almost the same. Okay, so you calculate this. Let me pause this to calculate. So I already calculate. The resistance needs to be around 178.2492. Okay, so this is for 5 volt signal. Sometimes you use the ESP32, it will produce 3.3, right? So same method. RC is 3.3 minus 1.55. Okay, divide by 25 first, 25 milli, to 3.3 minus 1.55 divided by 7 milli. So you get the range of the resistance for the 3.3 volt system. Okay, so I pause it first. So this is the answer. So for 3.3 volt output, you have to use 70 until 250. But for the 5 volt one, you have to use this resistance 138 until 492. But usually in the application note, they just recommend RC equals to 240 ohm. That is the standard they use. So instead of calculating, you can just use the standard. So RC is just 240 ohm. So that's it, how you can design the HCPL 3120. Just buy this around 7 ringgit, and as well as 240 ohm resistance, and I think 0.5 watt is 0.25 watt is should be okay. Okay, no power required here. Okay, so this is for MOSFET. For IGBT, if not mistaken, you need to have some sort of resistance here, but I never use it. I just use it directly. So try to design it. Don't connect the microcontroller directly to the MOSFET. So just use the Octocoupler. Okay, so that is how you design the HCPL 3120 and how to use it. Okay, remember, don't use this one just redundant. This one connection, make sure positive and negative is correct. This one positive, this one is negative. Don't forget to put the resistance. 240 is the standard. If you want to calculate, you also can calculate. And the connection 7 and 8, 6 and 7 goes to G, 5 goes to the to the S. Okay, source, not source, the drain source, the source of the MOSFET, and then also connected to the negative part of the power supply, and make sure the power supply is isolated. Okay, for the drain, no need to do connection. Okay, don't forget the supply to the line number 8, pin number 8. Okay, that's it for the gate drive.